What else? What else?
Nociceptors.
Okay. Exteroceptors versus interoceptors.
Tonic and basic.
Yeah. Moving on, tonic versus basic.
Thermoceptors.
Proprioceptors.
What did you say? Girl? What's the one you said? Oh, yeah.
Okay. Keep going. There's a few more. Huh? Chemo, so photo. Chemo.
Those are on general? Oh.
Thermal.
Some are special. What is
What else?
What are the nociceptors and mechanoceptors?
Nociceptors. Keep going. What else? Baroceptor.
No receptor. Oh, you would check that.
What else you guys have?
Tactile?
Huh?
Tactile receptor?
Tactile. Okay. Okay. Okay, there's one more general category, no one said yet.
Somatoceptors?
No. How about
Pain?
something that's found everywhere in the body, we call them? General, yeah.
Oh,
General versus what?
special.
Special.
Special sensory.
Special. Okay, so believe it or not, we went through all these vocabulary on Monday, yes?
Yeah.
So, what, I list these all together. Why? What do they all have in common? Why do they listen together?
They're in the head. The special receptors?
Photoreceptor, chemoreceptor, thermal, mechano, nociceptors. Because they're organized by the type of stimulus, right? So all of these is stimulus type, right? So photoreceptor, what's the stimulus?
Light.
Light. Chemoreceptors is what? The stimulus? Chemical. Thermoreceptor is?
Temperature.
Mechanoreceptors?
Movement.
Movement, physical movement. Nociceptors?
Pain.
Pain. And baro?
Practice.
Stretch. Okay. Okay. This one, why did I list them in order? I mean, in the same line.
Based on location?
Based on location, right? Location of the receptor, right? What's the difference between these two? This is found where? On your skin. This is found in
Internal organs.
inside, right? Inside internal organs. What about proprio?
Joints.
Joints, tendon, muscle. So kind of in between, yeah? It's inside your body, but not the internal organs. Make sense? Okay. Why not list these two together?
The
It depends on adaptation, right? Which one go away over time?
basic.
Good, basic. Whereas tonic will always be there, correct? And then tactile, what does tactile mean? Touch, right? Touch. Okay, so this is a quick review of last time. And believe it or not, it was all in part one, so now I'm gonna go to part two, part B. So all of these can be overlapped. Okay, so we can say general senses, and a general sense could be temperature, for example, thermoreceptor, correct? So they could overlap, because do we have thermoreceptor everywhere in our body? Yeah. You know it's cold because your hands, your feet, everything's cold, right? Okay, so yeah, it could overlap, okay, in other words. Whereas special is only located, specific area in your head, for example, and it's usually very complicated, much more complicated. We're going through all of this, all of these is dependent on the type of stimulus, okay, here. And, this picture just kind of shows you, what would you, here they call nociceptor on the skin, but what else can you call this? What else can you call this? Notice it's top of the skin. What else can you call it? Exteroceptor, agree? Yeah, so it's nociceptor because it's pain receptor, but because it's here in this picture, we can also call it nociceptors. I mean exteroceptors, agree? Okay. Whereas here, this is something in your cecum, which you should know where. What is a cecum?
Beginning of the large intestine.
The large intestine, right? Hanging on is the appendix, agree? So, multiple choice. Blank type of receptor will be found in this picture. What would be possible answer? You know, so I give you a sentence. Blank receptor would be found here. So what could be your possible answer? It would be intero. Good, that's one answer. What else? Okay. You think it's, yeah, okay, it could be general receptors. Okay, what else? Okay, why don't you talk to your neighbor? Turn to your neighbor and give me what else would fit in this blank receptor would be found here. So, I guess Jacob, you can talk to.
Wouldn't it be tonic?
Make a list of possible answers that you can fill in that blank.
Special.
But then you could like suppress it. I don't know.
Not the large intestine, not, what's it called?
Well, it's like clothing. It's like you can suppress that. You don't.
Well, you don't
Feel
feel
it.
it, but you don't feel any of your organs do anything. Do you?
I'm just throwing things at the wall, seeing if it sticks.
Do you? Unless you feel pain. That's a good question. So what did you say? Phasic.
Maybe.
Is your body phasic?
I'm not confident in that answer.
It's a special. No, that's general, right? Is it, it's not special, it's special, it happens, isn't that mostly like stuff that happens in your head?
Yeah, specials like gestational faction.
Which is all that stuff that's up here. General internal sector. And I would say barrel for sepsis. With stretch.
Okay. So raise your hand and you have at least 3 answers. How about 4 answers? 4 answers? 5 answers? It's like 4.
No, not
Is the max? Okay, let's hear from you who says 4. I'm sorry? Chemical receptor? Not really. I mean, do you know down here what kind of stuff you're sensing? I mean, what kind of chemicals? Your brain would say, oh, in the secret one, it just tastes sour. That's usually not the case. So chemo would not be. Okay, what else? What else might be a possibility? Barrel, okay, it could be stretched. Yes, I agree. Barrel. What else? Noci, yeah. If you have pain, like appendicitis, you will know, right? You will know. Okay, so this would be good. This would be good. We already said interoceptors, agree? And what else? What do you think? Would it be tonic or phasic? No, it would be tonic. If you have pain like appendicitis, you know you have pain, it doesn't go, it doesn't go away, right? It just gets worse, especially when it stretches out. Right. So I would say this, 1, 2, 3, 4, yeah, so it could be 4, right? 4 times the answer. So does that make sense, how you guys approach this here? Okay, it's not just about memorizing, but you gotta know what it is. And then if I give you a picture like this, you can tell me, oh yeah, you might find whatever receptor there. Okay, all right, let's move on. So now you go to tactile, which is the most numerous type of receptor. And a lot of them are mechano. What does that mean? They respond to movement, right? Movement of the receptor, like vibration, for example, touch, pressure. Tactile, sense of touch, where are we gonna find them? In the, where do we find tactile receptors? Skin, right? Back to the skin. And it could be either simple or complex. So let's make a table of tactile. Here we go. Versus. Okay. And so you know tactile, these are mechano. In skin. Okay? And they respond to sense of touch, pressure, vibration. Alright, so let's continue. For the simple, we can call them unencapsulated. Unencapsulated. And the more complex, that would be the encapsulated. So what would be unencapsulated? Well, 3 nerve endings, root hair plexus, tactile disc, and the encapsulated. What word do you see over and over again? Corpuscle, exactly. So when you see corpuscle, it's going to be encapsulated. Okay. And then the details are here in terms of, what the bulbs are, Krauss bulbs. Found mucous membrane, which is, and I don't want to say skin, I'll say integumentary system, it's more accurate. Integumentary system. And it can detect light touch. Okay, all right. So, they don't have a picture. Dang, okay. I'm gonna have to go online to find you some pictures. This is easy. There you go. Okay, so this, I skipped when we were in the integumentary chapter, but I'll pick it up now because I think it's appropriate to mention here. Okay. So, if you look at this picture, why do they call this corpuscle and encapsulated versus unencapsulated?
It has a capsule.
It has a capsule. So what's a capsule? Show you, this is encapsulated. This is encapsulated. This is encapsulated, right? So how are those 3 with the letter E encapsulated? How are they different than the other picture?
They have a lining around them.
They have a,
Lining around them.
Yeah, they have a cover around them, right? You guys see, there's this covering here. There's this covering here. The covering here, yes? Okay, so that's what we mean when we say it's more complicated, is encapsulated, tend to have the name corpuscle next to it, okay? Except for the Krauss and Boll. Okay. Now, this tells you touch, Paxillian pressure, corpuscle, pick up pressure. Now look at the location. You think that's, and Ruffini Ruffini, oh, this should also be corpuscle. It's also encapsulated, okay? So Paxillian corpuscle would be more like deeper touch, because you see how far down in the dermis it is. Ruffini corpuscle is more superficial, it's higher up. Okay, so they draw the picture to help you kind of figure out what kind of pressure we're talking about. Okay, what kind of pressure it will pick up. Okay? And then of course, definitely, Meissner corpuscle, look at where they're at. So what do you guys think? What kind of touch? Light or deep? Light touch. Like a breeze on your skin would be probably a Meissner corpuscle. Yeah? Okay. All right. And then the unencapsulated will be the more simple stuff, right? More simple stuff. That would be the free nerve ending. Look at where it's at. It's all the way up in the epidermis, right? We're up in the epidermis. Remember when I talked about the different types of burn we can suffer? First degree, second degree, third degree? So first degree burn, why does it hurt? Because the free nerve ending is stimulated, right? First degree burn is usually in the epidermis. So these are activated, and that's why you have pain. In like a sunburn, for example. You know, you're sitting out in the sun, you fell asleep. 2 hours later, you're kind of reddish, and that's a first degree burn. Okay. Whereas we have Merkel discs, which are in the dermis, you know, they're unencapsulated. And then around the hair, we talked about this already, around the hair you have the root hair plexus, so that you know when someone plucked your hair, right? Make sense? Okay, so I just insert this picture in to your slide. It was also in the slide for this integumentary system. Okay, so if you want to go ahead and snap a picture, it is newly added, part of a review from last week. And remember, they're all what? What kind of receptor? They're all mechano, and they're all mechano receptors. Okay.
What causes like pain tolerance?
Pain tolerance?
Yeah.
It's just a different person. The neurons fire, you know, these receptors fire, and then it goes to the brain, and the brain register it. And a lot of it has to do with your experience. If you're used to tolerating a lot of pain, then your tolerance will increase, right? Whereas if you're never had pain, well then the first pain episode you have is going to be pretty drastic. So it's experience.
So there's like a threshold change or not?
I think so. Yeah, it's partly adaptation. You know, so you always have that ongoing pain. Your threshold for pain is now increased because you're always experiencing it. It has to be much more severe than that for you to say, oh yeah, that's painful. So it's, you know, it's just like anything in life. Let's say you eat sweets. Okay. Well, if you don't eat a whole lot of sugar, the first time you have a cupcake, like, oh, that's really sweet, right? But if you eat sugar all the time, you know, you're snacking on candy bars, well, yeah, a cupcake is nothing because you're so used to a high level of sugar. So pain is the same thing. Okay, your brain will adjust based on your experience. Okay, let's move on now to taste. Gustation is taste. So what do you guys think? What are your choices here? What would be taste? Chemo, right? Because the food we eat are chemicals, correct?
Yeah.
So it'd be chemo, what else? What else might be?
Thermal,
I'm sorry?
thermal.
Thermal, yeah, you can burn your tongue, I guess, okay. But actually the sense of taste is not, it doesn't really have to do with temperature, it's just chemical, okay?
Oh,
Yeah.
nororeceptor.
And the answer I was looking for would be special, right? It's the chemo special sense, okay. So as you know, it's on your tongue, and you should know there are 4 papilla. Okay, you saw this word before. What is a papilla? Little hills, right? Little hills, those raised area. I call them hills, raised area. There are 4 types of papilla on your tongue. And let's look at them. Here are the 4. Oh, yeah, I like the picture better. Okay, here are the pictures. Okay. Of the 4 hills, the 4 raised area. They all have different names. Make sense? Okay. Now, in this picture, they're trying to show you this little nerve here coming out and the little round ending. That's the taste buds. Okay, so if you look at the picture here, it's happening to be the crack. So right here are the taste buds. So which papilla has the most taste buds?
The one you were just pointing to.
Right, valleys, right? Sometimes some textbook call it circumvallate, because like a circle, okay, circumvallate. So this is on your tongue, and when we have saliva mixed with our food content, it seeps down into the cracks. And when it seeps down to the crack, that's when it's gonna stimulate these taste buds, okay? So let's take a look at, yeah, so you should know them all by 4, but know that this guy is probably most important because it's where most of your taste buds are, okay? So in this next picture, I'm going to turn the picture 90 degrees, okay? So the crack coming down with saliva is up here. Okay, so turn the picture 90 degrees, so now instead of the taste bud going sideways, now the taste bud is up. Does that make sense? Okay, so the saliva is here, saliva is there, and this onion looking thing, that's a taste bud. Okay, that's a taste bud. So we have gustatory cell. What's gustatory? Taste. So that's a cell, that's a little nucleus there. And then at the very top here in this picture, what are these little guys? Microvilli. Aha, you saw that word before. What's microvilli? Small little extension, yeah? Why would you want that? Increase surface area so that you can pick up the chemicals, yeah? Yeah, pick up the chemicals, okay? And then connected to these taste cells would be this yellow thing. What's the yellow thing? The nerve. Aha, what cranial nerve? You don't know that. I mean, you didn't learn that because I didn't specifically break it down for you guys, okay? How about this answer? What part of the brain will this information be sent to? Insula. Right, we go to the insula. Okay, so here it is in real life. That's your tongue. What kind of epithelium is this? Let's review. What does that look like? Stratified, squamous, epithelium. Is it keratinized or non-keratinized? Good, non-keratinized. So that's your little taste buds here, okay? Here's the big picture, look just kinda like the cartoon that we saw. Okay, we actually can taste 5 different tastes. I'm sure you guys have seen this before, yeah, in another class. I think this is a new one. Most people know about the 4. Anyone heard of this?
Yeah,
Savory.
I read the book.
You read the book? Okay. Well, so what did they say? What is this like?
Savory.
It's savory.
Savory. What the heck is savory, right? Someone said it's like chicken broth, or whatever. All right, but anyway, that's our discrimination of taste. Okay. All right, so let's now go to the next chunk, which is with taste comes smell, right? Comes smell. All right, what cranial nerve? Olfactory, which is what number? Yeah, number 1. Where is it found? Krista Galley. Krista Galley divided 2 olfactory, you agree? It's right here below the frontal lobe. You guys remember this from last week? Okay. So, this was your exam question, wasn't it? Smell coming in, because you already have this area earlier on the semester, correct? So I told you nostril, inferior, what is this? Inferior nasal concha, this would be middle nasal concha, that would be superior nasal concha, right? Smell travels in. It would then stimulate nerve endings, right? I gave you nerve endings because I want you to understand that that's the end of the nerve. That's where everything starts, okay? So nerve ending, and then the nerve ending continue on with the nerve. And the nerve comes through the cribriform plate, right? You guys remember this ethmoid bone cribriform plate? That's why the cribriform plate has the little holes. Has the little holes. So here you go. That's the cribriform plate. And so this is the epithelium because it's lining, right? Lining this area here. So epithelium, and you have in the epithelium these little yellow cells with the little, gee, what are these? Hair. Almost like microvilli again, isn't it? Why? To increase. Why do we have these little hairs?
Increase surface area.
Hello? Increase surface area to pick up the chemicals, right? Pick up the chemicals. So, yeah, so then, you stimulate the little receptors here, the hair cells. It goes up. What's going on here? There's a yellow, and then there's a purple. What's the yellow and what's the purple? These are neurons. Because these are nerve, right? Remember I told you nerve ending? Right, nerve ending, these are neurons, okay, neurons. So the neurons go up, synapse. Remember this word from last week? What's a synapse?
Space between 2 neurons.
Right, so when they meet up with the next neuron, correct? Is that what's happening here? Yes. And so there's interneurons. So you know this as cranial nerve 1, right? But here in this picture they call it olfactory tract. Right, olfactory tract. So most of this is going to be what color? White or gray? White, because what is this thing here? Myelinated axon. That's why we call it a nerve, right? Cranial nerve 1. You guys understand? Pulling things together. And then it goes to what lobe of the brain? Insula. Okay, so here you go. And it goes to the insula lobe. But before we get to the insula lobe, will it have to go through the brain? What do you guys think? Yeah? And so what would that be? White matter or gray matter? White. Okay, so a lot of you guys didn't understand that. You put insula first and then you say white after that. It's like, no, you gotta be white before you get to the insula. Okay, so it goes through the white matter of the brain, and then it will hit the insula at the very end. Okay, insula at the very end. Okay. Does this make sense? You guys? Yeah.
So what happens to the chemicals? Like, does it stick to the receptor cell or not?
Yeah, these are the receptors here.
But the older molecules stick onto there,
Yeah, that's how what stimulate these little hair cells.
and then after they're done, they just leave.
No, not leave. It will bind here, and that would trigger the nerve impulse to go up this way, synapse here, and then go up the olfactory tract, which is what I've been doing, right?
Yeah,
That test.
What happens to the molecule after that, the older molecule?
It may
be absorbed?
be, once it stimulates, that's it. It's not gonna like hang around forever. Well, let's put it this way. Once it stimulates the olfactory tract, what do you guys think? Sense of smell, is it tonic or phasic? Phasic. Smell is phasic. You guys ever notice when you first step into a room that's stinky, you smell it right away? But when you stay in that room for another 5 minutes, you still smell the stinky smell? No, so it phases out, right?
Kind of, it's just not as bad.
Right, but you kind of don't notice it until a new person comes in and says, oh, why does this room stink? And then you remember it again. So the odor molecule stays there, but the brain doesn't register it as much anymore because it's a phasic receptor. Okay. So yeah, it just stays there. All right. So yes, as we go through these things here, I want you guys to kind of piece it together. So how is this sensory information gonna get to the brain? Okay. Now, let me ask you. Last time we talked about dorsal root ganglion. What? Dorsal root ganglion. What the heck is a dorsal root ganglion? Cell body of what?
Sensory nerve?
Sensory. Yes, you guys remember that? Cell body of sensory neurons. Where? Where do I find dorsal root ganglion? Along the spinal cord, right? Just outside the spinal cord. You guys remember that? And what root is it? Is dorsal root. Why don't we have that here? I mean, isn't smell sensory? That's what? It's, smell is sensory, but it doesn't involve dorsal root ganglion, does it? I don't see it on this picture. Why not?
Because it's up here, so it doesn't have to go back to the spinal cord.
Very good. Because the nose is here already, yeah? We're already practically clicked next to the brain. Why would you need to go down to the spinal cord and then back up? No need. So that's why you don't have dorsal root ganglion involvement. It's because of location. Does that make sense? So yeah, so just, don't forget your logic. It's not something difficult. Okay? It's pretty common sense. So yeah, okay. Anyway, enough of that. So here's the real life picture. This is the epithelium, and you see the little hair down here, all right, for the chemoreceptor. Vision. Dependent on light. So what kind of receptors? Photo. Okay. But let's look at the accessory structure of the eye first before we go to the photoreceptors. Okay, so basic vocab words. Everything has a name and anatomy. That little round bump is a what? Is a lacrimal caruncle. That round bump. Okay. This slit here, slit that's formed by the eye opening, that's gonna be the palpebral fissure. Okay, slit is a fissure. Okay. And we have medial and lateral commissure. Right? Medial and lateral commissure. We're connecting the top and the bottom lid. You guys remember commissure in last week? Okay, so we're connecting top and bottom lid, so medial and lateral commissure. Aha! Sclera. What is sclera? The whites of the eye. Whereas here, this would be what? Yeah, the color's the iris. But what layer is this over the iris?
Oh, the cornea.
cornea, correct, the cornea, and the pupil is the hole in the middle, right? Okay, so continuous with the sclera is the cornea. Make sense? Okay? Okay, let's look at side view of the eye. Does this look familiar? I hope so, yeah, we just had it in lab. Okay, so I'm not gonna cover those terminology again. But I do want to point out, and I'm gonna draw. Alright, so let's go superficial to deep. Most superficial would be the muscle, correct? What kind of muscle do we have? Superior rectus and superior oblique muscle, okay? We also have muscle to lift up our eyelids, right? So that's the palpebral. So what do you think palpebral means? Eyelid. Okay, eyelids, fancy word for eyelid is palpebra, okay? Alright. Alright, I'm gonna wake you guys up. You guys are falling asleep on me here. So, team up, and I want you to go superficial to deep. Okay, superficial to deep. Go ahead, I'll give you a minute. What do you think? Going superficial to deep.
So